our class starting now. Again, we jump to BFFs. I'm only going to have the screen up for a second while we look at the squaring function. All of those things that I kind of have like bracketed off, that's what we look at with just the graph. So I don't even ever need you to memorize those things. We just need to know what they mean so I can read them on the graph. So I'm skipping identity function. I'm going to the second box that says squaring function. And we are doing that one right there. Is it crazy? Okay, so squaring function, that's the name. So that's not even something that you have to write down. It's already there. You could also call this the quadratic function. That's too many R's. Or the parabola one or the x squared one. Now my stylus doesn't want to work. Either one works, or parabola, that's fine with me. And this is y equals x squared. So those two things you need to know. And then we remember parabolas are those U shapes. They always go through the origin, 0, 0. And then we kind of talked about this a little bit yesterday, where we talked about the pattern was like you're going like up 1 and then up 3 and then up 5. And each time you're just going over 1. If you just draw me a general U, that's fine, but it is nice to know kind of what the pattern is for the future. So I'm going to go over 1, up 1, and I'm going to go over 1, up 3. And then I'm going to go over 1, up 5. And it's the same thing on the other side. Over 1, up 1, over 1, up 3, over 1, up 5. This makes a very pretty parabola. If you just do a U, it's still a parabola though. And then this is the graph you need to know too. Everything else I'm about to talk to is kind of extra stuff that we'll have to know later, but you do not have to know for this Friday. Okay, now that we've done that, I'm going to move off of this textbook screen. I don't need it anymore. I'm going to make my screen really big. And we're going to talk through everything else. Some of these we'll have to come back to and do more specifically later, but others we can do right now on our own. So the first one is domain. Domain refers to what? The x's, very good. So we want to know what x's work here. So my arrows here tell me that it goes on and on forever. There's no holes, there's no gaps. This is going to have a domain of all real numbers. We're doing all interval notation though, so I'm going to write negative infinity to infinity. There's nothing funny about it. Its domain is negative infinity to infinity. If domain is range, then, or sorry, domain is x's, then that means range is y's. And so if I'm looking at the y's, I'm looking at what's the lowest y you see? 0. What's the biggest y you see? Infinity, good. I am going to use a bracket on 0 here though, because there was a point at 0. So I'm going to use a bracket there. Bracket 0, comma, infinity, parentheses. The next one is continuity. We did that yesterday. Is this continuous? Yes or no? Yes, right? We talked about picking up our pencil or not. We did not have to pick up our pencil, so it is continuous. All right, increasing, decreasing. Remember, we have to do this as we go across the page, so from left to right. So as I go across, I see what is happening now. Increasing or decreasing? Decreasing? We're decreasing until what x? What x value do we stop decreasing at? 0, good. So I'm gonna write decreasing, and I'm gonna write negative infinity to 0. As we talked about yesterday, I want my intervals to have like of 0 to be parentheses, because technically at 0, you're not increasing or decreasing. So I just wanted a parentheses. It's not included at all. Now, as we keep going across the page, what am I doing? Increasing. From what to what? Good. Zero to infinity. All right, I'm going to tell you more about specific symmetries later, but just looking, is this symmetrical or not? Yep, it's symmetrical. It looks like there's some symmetry there. We'll dive deeper in that. So I'm going to put a little dot there to know I have to come back. All right, boundedness. Ooh, do you remember boundedness from yesterday? That was the very last thing. It was like 19, 219, and I was like, this is boundedness. So I know that some of us might have tapped out or we didn't get it all the way clear through. Anyone think they want to help me with that? It can be bounded at 0. Essentially, bounded means like, is there a place that we don't get to go below or we like don't get to go above? And there is, right? If you look at our graph, there's a spot right here that nothing goes below that. Everything is kept above it. So it has a floor that it's bounded below it. It can't go lower than that floor. So we're going to say bounded below. Boundedness is below. Yes. Boundedness is the Y's, and exactly, yeah. And we'll look at more examples. We like barely touched that the other day, so we'll see more examples as we go. Next is the word extrema. Have you heard that word before? I know that you know what it is, but I know that you maybe haven't seen it as well. The word extrema, and I'm going to write something down here just in case I forget. Extrema refers to your max or your mins. Extrema essentially means the extremes. So I want to know, is it extremely high or extremely low? Where is its max and where is its min? Now, on these parent graphs, these family functions, they will probably only have one or the other, or they might not have anything. They may have no maxes or mins, and that's okay. Often, like if there's several like humps or something in a equation, that's not a parent graph. Like that's like something had to happen in order to get all those humps. A normal parent graph only has one or two things going on. This case, I just have one minimum at 0, 0. And so that's my extrema. Local means like at a small level, right? If you think about local government, that's like our city government. That's just like in a small area. If I draw this picture again, there's a couple different maxes and mins, right? But only one is like the most minimum, right? This guy is like the absolute. These guys are like high for its area, and this guy is like low for its area, but there are points lower than that, right? In this case with our parent function, you will have the max and the min of the absolute and local will be the exact same. There's not more than one, so it will just be the same thing for both of them. So here, my local extrema is a min at 0, 0. And my absolute is the exact same thing because there are no other maxes or mins. So for parent functions, they'll just be the same, but we'll look at other examples when the graph's a little bit funnier. All right, asymptotes. Do you guys remember asymptotes? A little bit. We're not really going to get in depth in asymptotes today, but basically they're like those dashed lines that we draw on the page when we did like rational functions. Don't draw them on here because there are none. There are none, and they're part of the drawing process. So when we get to them, you'll like physically see them because we had to draw them. It's like this is a rational function. If you have like the little like semicircle over there and the little like C over here, there's technically asymptotes on the axes because we get close to the axes, but we never cross it. Did you guys do those kind of functions in Algebra 2? Yeah. Was that when you guys were online? No, that was in person? Okay. We'll deal with those more later, so don't stress about it, but there are no there's no asymptotes here, horizontal or vertical. So we're going to say no, and we're going to say no. You can write NA, you can write no, you can write none, you can write nope, whatever makes you happy. And then we're actually going to come back to end behavior because I have to tell you what that is in a few minutes. Okay. The hard part about that is just knowing what it's asking for, like knowing that like what an extrema is, or knowing what the end behavior is, or knowing what boundedness is. The rest of that, all we did was look at this graph. I didn't look anywhere else. I didn't have to look anything up. I didn't have to get my calculator out. It's just reading the graph. So what I want you to do though for Friday, at least, if not the next time I see you, is write down all of the names, the equations, and the graphs, and then we'll go off from there, okay? In this, there's like room for 12 graphs, so it's like 4 pages of graphs. Since you just have to do the name, graph, and equation, it will not take you very long. It'll take you like less than 10 minutes because you're just doing 2-3 things. Cool. You do not have to fill in the other things. Okay. All right, we'll talk more about that tomorrow, but I got to get into some of the other stuff. So we're going to go back to the graph that we were just looking at. And we're going to do some of these other words that we just talked about with the parent function, but this is like a special graph that we drew on our own. So now we're cutting back to what we did yesterday. All right, just to remind ourselves, we're looking at this graph right here. This is my absolute value graph right here. And now I'm looking at asymptotes. Letter D says asymptotes. Did we draw any asymptotes here? Nope, we're not approaching anything. Again, we're just going back to where we were finished our notes yesterday. Everybody with me? Okay, good. I know I'm switching around a lot. Now we're just gonna follow along. Okay, no asymptotes. Maximum or minimum? Which one do I have? I have a minimum. And at what point is my minimum? -2, -1. My lowest point is right there. It's highlighted. And it's at the point -2, -1. I don't have a maximum because my arrows go up in the directions. And so it's just going to keep going forever. I'm never going to reach a high point. So I can write none for max. And for minimum, I can say yes. And I'm going to say at the point, -2, -1. What about symmetry? Does that look symmetric? Yep, we'll say yes. And then on the next side, there's 3 more that still go with the same graph. So you can just rely on my graph or you can keep switching back and forth. I've got domain, I've got range, and I have zeros. We just talked about those, didn't we? Domain is my x values. What do we think counts as my x values on my graph? Say again, Kathy? I think you're right. All real numbers. And how would I write that as an interval notation? Awesome. So it's all real numbers. I included everything. I have arrows going in all my directions. That is all good. Negative infinity, positive infinity. Now I have to do range, which is my y's. What's going on with my y's? What's the lowest point you see? -1. And what's the highest point you see? Infinity. So we're just going to do that. I am going to give me a bracket at -1. I'm going to include that point because it has a closed dot on my graph. So I'm going to go -1 to infinity. And then last are my zeros. This is actually a really nice graph. And funny enough, absolute value is one of your 10 family or 12 family function graphs. I think I mentioned this when I graphed yesterday, but the basic function on how an absolute value works is it just goes over 1, up 1, over 1, up 1. It's just a very basic like linear progression. And so that's how I knew I could just go over 1, up 1, and I've got a 0 at -1. And then I went over 1 and up 1 on the other side, and I have a 0 at -3. This is not an interval, it's just actually the 0, so I'm just going to list them. You can write like x equals -1 and -3. You can write -1 and -3. You can say x equals -1, x equals -3. There's no specific notation I'm looking for here. So whatever makes you happy, the zeros are -1 and -3. Yep. Yep, you can't really mess up zero notation. There's no intervals here though, so I don't need parentheses, I don't need brackets, I don't need anything like that. Okay, let's do another one. This one says y equals 3 minus x squared. What kind of graph am I gonna get? Parabola. Is it gonna be upward or is it gonna be downward? Down, why? -x squared, very good. So I've got a -x squared, which means I've got a parabola facing down. Does anyone know what this 3 does? Say again? y-intercept. That's, I go up 3 from 0. So I'm going to go 1, 2, 3, and I'm going to put my dot there. And then I'm going to do my parabola graph. You can just do an upside down U, that's fine. I also kind of brought up the idea of the pattern of quadratics yesterday. So you go like either up 1, up 3, up 5, or this time we're doing down. So we're going down 1, down 3, down 5. So go over 1, down 1, over 1, down 1, 2, 3. That's enough for me. I'm going to do the other side now. Over 1, down 1, over 1, down 1, 2, 3. Now, that helped me on the like absolute value one to make a nice pretty graph. This one, even though I was really careful about using the pattern, do I have zeros that are exact? No, I'm gonna have to use my calculator. So if you wanted to just say like, screw it and not do the little dots exactly like I did, you could have just run upside down parabola and known that you needed to get in the calculator later. Does that make sense? Okay. This is just my general idea of what's going on, so now I can answer these questions. Is it continuous? Yes or no? Yes. We good on that? All right, areas of increasing and decreasing. Remember, as I go across the page, left to right, what is happening? Increasing until, what's my X? That's your Y. Zero. We're really tempted to do our Y's on that one. Just remember, X is what matters. X is important. So I'm on 0 for my X. So I'm increasing from negative infinity to 0. So I'm going to write increasing, negative infinity to 0. And then I'm going to decrease from 0 to negative infinity. That's just what my graph does, and that's my interval. Decrease, 0 to positive infinity. Did I say that right the first time? I don't think I did. I think I said negative infinity, didn't I? We're doing x's, so my x decreases from, or the function is decreasing where an x is 0 to positive infinity. I'm sorry. It's already confusing and I just said it wrong, so it's my fault. All right. We ready to look at bounded? Is this bounded above or below? Above, right? There is a ceiling essentially that I will not go above. It kind of keeps me knocked down and I have to stay below that the whole time. So it is bounded above. All right. What about asymptotes? Did we draw those? Nope. None. What about max or min? What's a max? And where is it at, Jared? 0, 3. Very good. No min in this case, so I'm going to write none under min, and under max, I'm going to say yes and say 0, 3. What about symmetry? Is this symmetric? Yes. And then now we're on domain, range, and zeros. What's my domain here? Good. There's nothing funny. There's no holes or no breaks or nothing crazy. And I've got arrows at both sides. So those tell me it goes on and on forever in the x direction. Negative infinity to positive infinity. What about range? This is now my y's. What's the smallest y you see? The smallest y. Negative infinity. And then what's the biggest y we see? 3. So this one is opposite. I'm going from negative infinity up to 3. I need to remember to write the small number first. So I write negative infinity and then I write positive 3. Since there is a point at 3, I am going to use a bracket. And then last are my zeros. As we already said, there's no pretty like exact point that it's at. So we got to go in the calculator. We're just going to graph it and find the zeros. So let's do that really quick. Where's my calculator? So we're going to plug in 3 minus x squared in the graph. I'm going to do second trace, 0. Okay, I'm left bound of the positive one. And I'm now right bound of the positive one. And I found the positive 0 to be 1.73. Now, I would bet money that the negative 1 is negative 1.73. Anyone think that's a fair bet? Since it's symmetric too, and it's centered on the y-axis, it should be the exact same point on the other side. So I'm going to say negative 1.73. Sometimes it's good to work a little bit smarter, not harder. Okay, this is a good natural stopping point, and I think we've earned a lunch, don't you think? We're going to come back around 12:22, 12:23, so just be ready to go. Go get your lunch, go get a drink of water, go to the bathroom, go do what you need to do. Yeah, we'll start up again soon.
Wait, Coach White, what did you say? Like what time?
12:22.
Okay.
Yep, you guys are free to go, and I'll see you again then, okay?
Okay.